So, what is an index? Well, the standard metaphor are a phone book and a Rolodex or a library index card. Anyway, think of it this way. So I have a collection of 3x5 cards and I shuffle them up and I dump them down and now I want to find somebody. What you have then is my desk. What I should have done was taken them and put them in order, so now I can find them much quicker. And that's what an index is. I think everybody understands that. Now, the SQL will always use an index if it's available. So think this over again. Let's say I have a table of data, and I have 100 rows in there, 1,000 rows, I don't care. And there is an index that has this information sorted. Will SQL use that index if it's available? And the answer is, of course, no. SQL may use the index. The query optimizer uses an algorithm to look at the query, then to look at the data and makes the decision if the indexes are the most optimal way of retrieving the information. Sometimes, actually many times, SQL will make the decision that it's just easier to scan the entire page where the information is stored or the extent and retrieve the information that way. So, in that situation, your index didn't do you any good. What is the most important thing to aid indexes? It is update statistics. SQL keeps statistics on the efficiency of indexes, the changes in tables, etc. And SQL uses those statistics to make the decisions with the query optimizer that I just talked about. As I recall, the SQL statistics on an index on a table are updated whenever the table changes by 20%. So a 20% change will fire and update statistics. So that said, that may be just fine and you can change that. But the most important thing are that the statistics are current. The types of indexes. I happen to like two different taxonomies, taxonomy by storage and taxonomy by column designation. So by storage, heap. When you first create a table and dump information into it, it goes into the heap, just like my office table that I'm looking at here, with stuff just laying all over it. That's a heap. By the way, heap storage should almost never keep your tables in heaps. Occasionally you do that if it's a temp table and that kind of thing. A clustered index. So now a clustered index, we take the information and we reorganize it and it's now in a logical clustered method. So we use the key to come through and organize it that way. Non-clustered indexes are built on top of a clustered index. So a non-clustered index would have other columns in there and it has pointers into how to retrieve the data off the clustered index or into the table itself. Column store indexes, that's a little bit beyond scope here. A column store index is an index that was first in SQL 2012 and enhanced in SQL 2014. Column store indexes are based on in-memory databases, and that's the Vertipack engine. It's the compression engine. So what we do there is we take these indexes, and if they have the same value, then we shrink them down and put a pointer in. So that said, there's a lot of limitations currently on column store indexes, but beware of them that are going to become more and more common as we move to in-memory databases. XML indexes. An XML index is a way of indexing an XML document. I'm a fan of XML. I'm not crazy about XML indexes, though. They can be really slow in their performance because they have to do what's known as shredding the XML document. So anyway, you can really get performance problems within XML documents. A spatial index. A spatial index is a special type of index that's designed for spatial data. Spatial data gives me the ability to draw maps, and I can index based on that. Now, by column designation, the primary key. All right, so when I create a primary key, it creates a clustered index. And the primary key then now is the key that we use to enforce uniqueness in our database. And our primary key is used for normalization. And normally we would assign a primary key to a table. By the way, if you're not familiar with the concept of database normalization, please pause immediately and write that down. And then as soon as you're done this course, go over to lynda.com library and look up normalization for databases and make sure you are familiar with normalizing a database into third normal form and also denormalizing a database. A unique key is very similar to a primary key. The difference is a unique key allows nulls, where a primary key does not. Included columns. An included column index is one in which we have a number of columns, and normally we would create an included column index because quite often your users are running queries where they have a certain amount of columns they're selected, and it's the same over and over again, and we're going to take those same columns, put them into a included column index, and that's then also referred to as a covering index because that index has the columns that they search on. So if we have a table with 50 columns in it and there's 4 of them they search on, then we can create a covering index and it will speed up those particular queries. Partitioned indexes. This is an enterprise feature. We can take a table and break it out. This is very common in data warehouses, so we break apart large tables. So the old stuff hardly ever changes, so we leave it over there and we store it in a certain location. And then we have different indexes by different dates. And say that we are constantly loading information into the current month. We can create a partitioned index that will only contain the information for that month only. Filtered index. A filtered index is one that has a where clause, and we use that once again if we're running certain indexes that have where clauses. Index compression is a relatively new concept for in-memory databases so that we can compress the index and take up less space in memory.